Welcome to the open day, the virtual open day for the School of Mathematics, Computer Science and Engineering. What we're going to do today is I'm going to introduce us. We're going to talk to you a little bit about the school, what we do in the school, sort of courses that we have in the school. Just before we actually start, if I can just point you at the bottom of your screen, there's a Q&A icon down towards the bottom of your screen. If you click on the Q&A icon, you can post questions during the talk. One thing I would like to do though is if you could open your Q&A box, and what would be really helpful for us is if you could post which subject or subjects it is that you're interested in. For example, are you here for computer science? Are you here for mathematics? And so on. So it'd be really useful if you could just post which subject it is you're interested in. Thank you. Okay, so the host for the session you can't see at the moment is Neil. Neil is a journalist and writer here at Hope. So he's sort of in the background making sure things run okay. I'm Mark Baxendale. I'm the assistant head of the School of Mathematics, Computer Science and Engineering. I also teach on computer science, information technology, and electronic and computer engineering and robotics. We've also got Neve, who's a student here at Hope. Neve will be keeping an eye on the Q&A sessions, and she's happy to sort of talk to you about anything to do with student life here at Hope. So yeah, thanks for posting the subjects you're interested in. So it looks like we've got computer science, maths. Oh, okay, and then possibly AI and robotics. Okay, thank you. Then in terms of the colleagues we have with us, we've got Andy there, we've got Nicholas, we've got Emanuela, we've got David.
Hi.
And we've got Ralph.
Hello.
So what I'm going to do now is I'm going to share the screen with you, and I'm going to basically talk through a presentation with you. So you should now all be able to see this presentation. Okay, so this particular open day presentation is for these courses. So artificial intelligence, it's either the BSc, which is a 3-year course, or it's a 4-year course if you do a year in industry. All of these courses are available with the year in industry option. So you've got the BSc 3-year artificial intelligence, or the MSci integrated masters. I'll mention a little bit the difference between those in a moment as we start to talk about the courses. So artificial intelligence, computer science, electronic and computer engineering, information technology, mathematics, and robotics. So those are the courses that we run in the school as undergraduate courses. Okay. Just to introduce you to the staff in the school. So the heads, well, there's 2 heads. There's the actual head of school over on the left there is Atulya. He's the head of school. And there's me, the looking rather different there. I'm the assistant head of school. Probably need to change my photo. Assistant head of school there. Okay. Then now some staff teach on a number of different courses, but generally we're grouped according to the courses. So computer science staff, we've got Nicholas, who you've just seen. We've got Kapil, who isn't with us. We've got David, you've just seen. Neil isn't with us at the moment, and isn't with us at the moment. So that's computer science staff. Although, as I say, staff do teach on other courses as well. Mathematics, we've got Pavlos, then we've got Andy, who you've just seen, and we've got Graham. Then robotics and electronic and computer engineering, we've got Emanuela, who you've just seen, Anyarada, and Ralph, who you've just seen. Okay. As university, school, or departments go, we're quite small, and that's intentional. So we've got a broad range of subjects, quite a number of different programs you can do, but with quite a small staff and quite a diverse staff with a lot of different backgrounds. You know, so we've got engineers, mathematicians, physicists, and so on. Okay, we've all got very different backgrounds. We're a small, enthusiastic staff. Okay, and as a result of that, our teaching is excellent. You can see that we've got gold status. Well, the university's got gold status in the Teaching Excellence Framework, the TEF. And because we're enthusiastic and because we know our students one by one, we know our students by name, we do very well. Currently, we're ranking in the 2020 Guardian University League table. The computer science course ranked 8th out of 105 institutions in the UK. So this is in the UK, the computer science course ranks 8th in the Guardian League tables, and it ranked 2nd for student feedback. If we hop over to the Times Good University Guide 2020, the computer science course ranked 1st in the UK for graduate prospects. Okay, so we're really proud of that. This is because not only I mentioned we have a small, enthusiastic staff, we have modern, well-equipped laboratories. We'll see some photos in a moment of those, and some of those are quite new, and some refurbishment has gone on as well. But also not just the physical resources, but the curriculum. One thing we really do, and this is quite unusual again at university level, is we keep the curriculum up to date, really fresh. We're always looking at what's the emerging technologies and so on.
Yeah, and this is particularly important in the current climate as well, because technology, if there's one thing, everybody's gone into lockdown at the moment, and everybody assumes nothing much is happening. But in the areas of technology, it's bounding forward fantastically because everybody's stuck at home and that's all they can do at home. So you'll find that the technology's changed dramatically over the time we've been locked down. And we're trying to reflect that in the curriculum as we speak. There's been a number of meetings, Zoom meetings, obviously, where we've talked about how to modernise the curriculum. And that's an ongoing process. We're well ahead of the curve on all of this stuff, by the way, because we're always looking at new types of ideas, new curriculum stuff, really, and looking at what's the next big thing. And we've tried to incorporate that in our courses as well. We very often look at what's called the TAOBE index, which is an index of what employers are actually looking for out there. What skills are they looking for? Are they looking for a specific programming language or a specific way of doing things? Are they looking for AI? Are they looking for data science? Are they looking for something else? And we try to tailor our courses to fit those skills. So you'll find what's on the curriculum basically evolves throughout the years. There's a core of it that stays the same, but particularly in the last year, we tend to find that changes nearly on a yearly basis to basically address academic and employees' needs.
Okay, thanks, David.
And also, it's exactly the same for maths, believe it or not. We're constantly looking at changing the curriculum to suit the needs of students who are coming through at the moment. You know, you might think maths is the same for years and decades, centuries and stuff, but it's a constantly evolving subject. You know, we use technology within maths as well, so which we'll come on to later on. But that's just the way modern science and mathematics is these days, is you've got to know something about technology in order to succeed really as a modern mathematician.
Thank you. Also, we have small class sizes, particularly in the practical sessions. So in lab sessions, seminar sessions, and also we have small group tutorials. These are generally quite small, which is why we get to know our students by name. Some of the lectures may be larger, because there is some sharing of teaching between some of the courses. So you may be in a large lecture. This is, of course, assuming that we're back to normal in the next academic year, which we may not be. And by the way, we're planning for delivery of courses in various scenarios.
Yeah, Mark, when you say large lecture, it's not like a lot of other universities, though. Because,
Yes.
as I said, I used to work.
I think relatively speaking,
when I was at another university, I used to teach the first year there, and the class size was 200 to 300 people. Now we haven't got the physical space to accommodate that number of people in a particular class, so we're talking about class sizes of 30 to 40 at most, and normally lab sessions are about 20. So because we've got small class sizes, that changes the dynamic of how you interact with the students. So rather than giving lectures and basically walking away at the end of it, not seeing the students again, we get more of a familiar feedback, more of we get to understand the students' weaknesses and strengths in a far more intimate way. So we can gear their particular course around what they want and basically give them exercises to help them, or to basically really push them in a particular area. And that becomes particularly important when they start the dissertation in the third year, because by that time, you need to produce some projects that are quite complex. You're working more independently. So you basically want to do something that you like, really. And by that time, because we know what you like and what you're good at, we can basically point you in the right direction. So it's a far more closer relationship than at most universities, the way we run our courses.
Yeah. Okay, thank you, David. So just moving on, just to show you some photos of the facilities. So this is a typical teaching lab. One thing to say, of course, in a normal open day, you'd have been in the school premises, so we could have shown you round. But one thing that doesn't come across here is that the school is based basically on 2 floors, and it's dedicated to the school, so it's a dedicated space. The labs are all in the same place as the staff offices. So basically, we are literally opposite the labs. And again, this is quite unusual in the university setting.
Yeah, sorry, Mark. That is quite unusual in the university. And the other thing to note of that as well is all the lab sessions and all the tutorials and so forth are normally run by us as well. So not only do we do the teaching, but we run the lab sessions and everything else as well. So you have a lot of contact with us. And as Mark said, these labs here are literally 1 corridor's width away from our rooms. So if you've got a problem after a lesson, basically you just pop across the corridor and see us.
Yeah. So there's a number of different computing labs throughout the school. I mean, basically there is no problem getting onto a computer with specialist software that are required for the courses. Just moving on, we've got a temporary virtual reality lab.
Yeah.
Which I think we're going to develop a bit further. I think this is just a temporary, isn't it, David?
This is a temporary one. Basically, we do quite a lot of VR stuff in our on our course for the computer science course as well, particularly in the third year. And it's becoming a bigger and bigger thing, really, as spatial computing comes to the fore. So we're actually going to invest in a full VR lab, a simulation lab, a spatial computing lab. And we're basically equipping that at the moment as we speak, or starting to anyway.
Yeah. Also, the university has taken an interest in our virtual reality facilities, particularly in view of how do we deal with teaching if we have a crisis like the one that we're in at the moment.
Yeah. Yeah, I mean,
also developing a specific teaching laboratory within the university, which
That's
has
right.
got the virtual reality equipment within there as well.
That's
Yeah.
right. Yeah. Yeah. So basically, we're at the heart of a lot of stuff. But one of the briefs I've got actually in the last few weeks is showing to other departments how you can actually use this type of equipment for their particular curriculum, and basically doing demos and proof of concepts for things like geography and other subjects, history, whatever. But at the core of it is the technology that we're using here is VR technology, and to actually create that, you can see how it's adaptable to many, many different circumstances. It's a very, very creative subject, computer science and maths as well, and IT and AI in particular. It's all a hot area at the moment. And if you're outside those areas, people don't often think how creative it is. But basically, you're very often creating artifacts. You're creating stuff for other people to use that can have real changes, economic benefits, economic impact, social benefits, and change people's lives quite dramatically.
Okay. This is one of the new, well, the virtual reality lab will be new, of course, but this is also one of the new labs, the robotics lab, new for this year. And I'll just quickly scroll through a number of the robots we've got in that lab. These are all brand new robots the students get to use.
We have, I'm just saying
Sorry.
briefly. Now we also have free 3D printers.
Yeah.
So I think it's important what my colleagues were saying, because basically the message is that you have the possibility in these labs to develop things that you like. So, I mean, we can prototype stuff, we can design and develop projects. I think this is an exception, but we even, I think Mark, during the last few months, he was even sending some equipment to the premises of the student. So what we are trying to do, I mean, again, this is a really exception.
Situation. Yeah.
But the message we are trying to give you is that you really have the possibility, we really have the possibility to know you and to try to establish a one-to-one relationship. And even for yourself, you can develop, things that you are more keen to develop.
Thank you. Also, there's a dedicated electronics lab, again, brand new for this year. This is actually different to other electronics labs that you'll find in other universities. We specifically built, so generally an electronic engineering lab will have full height benches with stools. But we specifically had a bespoke design here, which is a hybrid of a full height bench and desk height with integrated computer. So we have a computer and test and instrumentation for electronics all in one workstation, reflecting the fact that we tend to develop with both software and hardware at the same time. So that's again brand new for this year, all newly equipped. So that's a quick view. So there are more labs than we've shown here. That's just a sample of some of the key labs. Just a bit about, just before we go on to look at the courses, just want to mention our research, because at university level, the research that staff are doing is really important. It's really important that you're being taught by staff who are research active, and all staff in the school are research active. Now, we spoke about the TEF, the Teaching Excellence Framework, earlier. There is an equivalent for research, the Research Excellence Framework, which is, this is an independent review of our research, and it's carried out every 5 years or so. The last one that was carried out was 2014, and the next one, I think, is 2021.
Yeah, it's been delayed because of COVID.
It's been delayed because of the current crisis. Yeah, but this is our performance. And by the way, we're more or less ready for the next ref, and we're expecting to do quite a lot better than this. This is from 2014, and we've actually come quite a long way since then. But just to give you those results, because we're proud of these results. And this kind of reflects the fact that we are good. So we've talked about how good we are at teaching. We're also good at research. Now, this is quite important, because what tends to happen is that universities and then departments and schools within universities, they tend to fall into one of two camps. They're either really good at research or they're really good at teaching, but very rarely are they good at both. And we are good at both teaching and research. Now, that's really important, because if you're being taught by people who are good at research, by definition, you're being taught by people who are at the forefront of their discipline. And especially for the sort of courses we're talking about, that's really important.
Yeah, we've got this philosophy of research-informed teaching, where we try to feed the current research that we're involved with into our teaching material. Because on the other side of the coin, there's nothing more boring for a teacher to actually bang on about something that they're not interested in. If you're enthusiastic about the subject, you'll probably teach it better. So we try to teach stuff that we're actually interested in. And hopefully you'll get enthusiastic too about the subject.
Yeah. So just very briefly, the results of that last REF, Research Excellence Framework exercise, was that 100% of our research outputs were deemed to be, well, basically at international level, internationally excellent or internationally recognised. So research outputs are things like, so we usually publish the results of our research in academic papers and articles in academic journals, basically. And they were deemed to be at international level. So basically they're good quality. They're saying that our research is good quality. Research intensity is something they look at, or they did then, which is basically, how much research we're doing, the quality of it and so on. And in the Northwest, we ranked 5th for research intensity. Now this is a really good indicator, because I spoke about this, about being good at research and being good at teaching at the same time. We're up in the Northwest, we're up against good research intensive universities, such as Lancaster, University of Liverpool, University of Manchester. These are universities that would say they are excellent at research. Okay. So to rank 5th up against those universities, and yet also be really good at teaching, and we're very proud of that. So it's a kind of indicator that we are good at both teaching and research. Should we crack on with the courses then? So
just before you do, Mark, sorry.
Yeah, go on.
There's been a few more attendees who have joined.
Sure.
If you could just go into the question and answers box and just say, if you haven't done already, what subject that you're actually interested in. That would be great. It's just for our information, really, just to see.
Yeah. So you should see
which courses.
Sorry, Andy, you should see down at the bottom of your screen, you should see a Q&A icon. So if you click on the Q&A icon down at the bottom of your screen, it'll take you into the question and answer box. And then, as Andy said, it'll be really helpful for us if you could just type in which course or courses it is you're actually interested in. Thank you. Okay. And sorry, just for those who have joined us, also just to say that we've also got Neve, who's a student here at Hope, who will keep an eye on the Q&A and is happy to answer questions about their life at Hope. Okay, so back to the courses then. So artificial intelligence, and then we'll talk about computer science and information technology. So David, if you want to just take that away.
Yeah. Okay, so this is a new course actually that we put onto the books relatively recently. The philosophy behind artificial intelligence is in the first year that what you'll be looking at is a broad, a number of different subjects within artificial intelligence. When people actually say AI, that you're actually looking at a number of different types of technologies, and a number of different types of philosophies, and a number of different types of theories, and you can't basically cover all of them. There's very few people who are experts in all aspects of AI. So in common with the philosophy of the other courses, what we do is in the first year give you like a smorgasbord of different types of AI and compare and contrast them. So what you'll look in the first year, we have like 2 or 3 week taster sessions on different aspects of AI. So you'll be looking at things like fuzzy logic, look at Bayesian machines, you'll be looking at Markov models, you'll be looking at things like standard neural networks, you'll be looking at things like decision trees and so on. Lots of different types of AI systems you'll be looking at in the first year, and you'll be doing exercises on each of them as well. Now in the second year, you'll be focusing more on more specialist things. So you'll be looking at essentially more advanced types of machine learning. In effect, you'll be looking at things like deep learning in more detail in the second year. You'll really encounter it much in the first year because that's the foundation year for AI. In the second year, which is the really cutting edge stuff, you'll be looking at things like deep learning, and you'll be looking at how to integrate them in with databases and so forth. In the third year, you'll start looking at very specialist bits of AI. So you'll be looking at things like how you can actually use fog computing for AI, how you can integrate it into specific machines, how you can actually improve specific algorithms and so forth. And you'll be looking at the nuances of deep learning in the third year. So each year it progresses, it looks at more and more specialist topics. So you can focus in on the areas that you want to look at within the AI course itself. So it may be that you want to look at looking at small level AI that runs on small devices, sensor devices perhaps, or it could be that you're interested in big AI to crunch data, or it could be that you're interested in using AI for a specific purpose. So for instance, you might be tracking body movements as that picture shows there, or it could be that you're looking at facial recognition or facial analysis to do things like emotion recognition and so forth, or it could be speech analysis or speech processing, or it could be textual processing, which is used an awful lot in things like Facebook and Twitter and so forth. So you'd be looking at all of these are different branches of AI that use some similar tools, but then go into specific details and become a bit more specialist as you go through the 3 years. And we try to reflect that in the course itself. The actual languages that you use on the AI course to start off with is essentially Python you'll be using in the first year to do a lot of AI, but you'll be encountering other languages as well. So you'll be looking at things like C as well, C++, and even JavaScript towards the end of the course, because a lot of AI is now coming through the browser itself and going onto small devices. Whereas once upon a time you had to have specialist hardware to run some of this stuff. Nowadays you can run it on mobile phones. So we're looking at different ways you can do that and how you can integrate it into lots and lots of different things. Everything's becoming smarter at the moment, and we look at how you actually utilize that, how you can make things smart, how you can actually incorporate smart into different types of systems. Okay.
Thank you. Just before we move on to computer science and information technology, we did get a question about where is the robotics and AI subject, where do they take place? Just to say that all subjects that we're talking about here take place in the Francis Mary Lesher building, the FML building on Hope Park, and basically within the school's premises. So we occupy the top 2 floors of the FML building, and that's where all the teaching takes place. Occasionally there'll be a lecture elsewhere on that campus, the Hope Park campus, but all the practical seminar sessions all take place within the top 2 floors of the FML building. Sorry, David. So yeah, computer science.
Shall I continue with computer science?
Yes,
I'll continue
please,
yeah. Okay. So the idea, again, the same philosophy applies to computer science and information technology. We start out relatively broad, looking at a number of different types of systems and software and programming languages and so forth, and we get more and more specialist as we go throughout the 3 years. So the fundamental philosophy behind computer science is essentially software development. You'll be developing software all the time. So you look at things like algorithm design, computer systems, the type of programming that you'll be looking at. You'll be looking at a number of different programming languages. Again, you'll look at Python, you'll look at Java, which is a big part of the first year as well, if you're doing computer science. You'll be looking at C, if you do the additional parts of computer science as well, because it's used out there. Again, I mentioned earlier about the TOB index. All of these languages aren't just plucked out of the air. We actually do some analysis about what people are actually asking for in industry and academia. And we base our curriculum on those needs of industry and academia. So the languages that you'll encounter are the ones you'll see out in the wild. The same for the software development techniques that we use on the course as well. They're being used out in the wild. And very often, that's one of the reasons why you have such a high employment rate. We basically give people skills that are required out there, that are in demand out there. So in the first year, you'll be looking at, again, it's 2-week sessions looking at different aspects of computer science. So you look at things like algorithm design, various different types of computer systems, different aspects of programming and so forth. As you go through the second and third year, the second year you'll be looking at things like database development and software engineering and object-oriented design. And then finally in the third year, you'll be looking at things like mobile app development and IoT development and virtual reality and augmented reality development. So looking at specific aspects of how you can actually use some of the things you've learned for a specific platform or for a specific purpose. Again, for information technology, it's a slightly different philosophy to computer science. When people ask me what the difference is between computer science and information technology, computer science is basically understanding how a computer works underneath the hood, whereas information technology is using the computer as a tool to perform some other type of task, really. But in essence, it's very similar. There's a lot of crossover between the two. It's how far you see it as a tool and how far you see it as a learning implement in itself, an experimental apparatus in itself. But with information technology, again, we start off relatively broad and we get more and more specialized as we go through the 3 years. And the philosophy behind information technology is essentially web and mobile development. Look at how things are being incorporated into the browser and so forth. Again, we look at algorithm design in the first year, essentially through Java again. And in the third year, we look at advanced web development, how the web is being used for lots and lots of other purposes apart from just firing up web pages, how it's being used in a more intelligent way, how you can deliver things like entire software operating systems through the browser nowadays, or as I said before to the AI people, how you can actually do AI through the browser nowadays without any specialist hardware, how it's getting integrated into the computer operating system itself so you can actually run at full speed programs inside the browser. And we look at how that's been done. The advances, the massive advances that have been done with mobile development, loads and loads of advances has been done on mobile phones, but more and more things are being developed for smart devices, small devices that get integrated into the environment. They've got to work in a fundamentally different way. They're very often not always online. They can be left in isolation for weeks at a time. They've got lower compute power. They normally have to operate in real time. So it's a different way of programming them, really. And we look at that philosophy as well, how we actually do things like real-time programming on these devices.
And if I can say something, this is very hot topic, you know.
Very hot. Yeah, sorry, Emmanuel. Yeah, it's all of this stuff that we're looking at are hot topics. All of VR. I mean, I'm obsessed with VR and mobile development and IoT development, and I get really into this type of stuff. And it's in demand at the moment. It really is in demand, apart from all the demand of AI at the moment as well. And it can be incorporated into lots of other things as well. It fits really nicely into the robotic stuff, you know, vision systems, IoT devices, small devices. Andy was talking about mathematics before. A massive growth area is things like data science, where you've got to have a good knowledge of mathematics behind it for it to work properly, and you can incorporate AI into that. So all of these areas are quite good. I think we should mention actually is if after a few weeks you don't like the course you're on and you want to swap over, we've got a lot of flexibility to do that as well, because we all operate in the same department. So if you want to swap between IT, computer science, maths, or robotics, there's a lot of flexibility there for you to do that.
Yeah.
Okay.
Okay, thank you, David.
Just to say a minor thing, because for example, when David is mentioning also mobile development, basically you will be provided with tools in order, for example, to develop apps for the phone. Mm-hmm. And just think about what is going on, for example, with COVID now, you know. So it's really I mean, you're going to have tools that can be really useful. I just want to say that.
But in the third year, you do a dissertation, and the number of dissertations that are aimed towards doing stuff with COVID is incredible at the moment. it's nearly all of them, which is good.
Yeah.
They're trying to solve a specific problem.
Yeah.
Some of them are excellent, actually. Some of them are really, really good.
Great, thank you. So mathematics, Andy?
Yeah, sure. Okay, so with maths, our first year is essentially trying to get everybody on the same level playing field. So we have people coming from different maths syllabi and doing A levels, doing other sorts of qualifications. We even have people from abroad as well coming over, some international students who have done different things within their sort of courses. So the idea with first year is that we do lots of different courses. We always start from the basics of mathematical logic and how we can think mathematically, and then we build that up then. But sort of things that we cover, we do things like number theory, so looking at the structure of numbers and things like that and how they relate to each other. We do lots of algebra, geometry, something called linear algebra, which is the solution of multiple equations at the same time and things like that. Vectors, lots and lots of different things in first year. Something that we also do in first year is we teach programming as well. Programming is a really useful tool, regardless of whether you're a pure mathematician, an applied mathematician, someone who works in statistics or whatever. You're always going to be using some sort of programming at some point as a mathematician. So what we do is we introduce programming through a package called MATLAB. So it's an industrial piece of software. I think the most famous company that uses it is NASA, who use it for as well as part of their modeling for rockets and things like that. So it's a really good programming language to actually start on. As we move into second year, we start to get a little bit more specialized in the topics that we look at, and we start to tend to delve a little deeper into those topics that you might have just touched on in first year. Third year is a very much more specialized area and reflects the sort of interests of the teaching staff. We have Graham, who's a pure mathematician, who is really good with geometry and group theory and just lots of pure math stuff there. Myself, I'm an applied mathematician, so I look at things like dynamical systems, chaos theory, and some more specialist subjects like calculus of variations. And we have Pavlos as well, who's a bit of a hybrid between pure maths and applied maths. So he does lots of different things which cover both subjects. In second year, I should also mention, we do some statistics in second year, and we also teach another programming language called R, which is a statistical analysis type of software. I show my students at the beginning of our program some job adverts, very recent job adverts, usually within the last few days or week. And a lot of the statistics ad jobs require R programming as a desirable quality, you know, for people to have in order to get this particular job. So that's one of the reasons why we teach R. We also do, David mentioned about projects in computer science. We also do projects in maths as well, and these cover a massive range of subjects. So if there's something particularly that you're interested in, particular area of maths, then you can have a little look at that in, you know, as part of your project. But we also have plenty of projects available for students to actually look at as well.
Okay, thank you. So electronic and computer engineering and robotics. So electronic and computer engineering, it's basically the overall philosophy of this course is that a graduate will be able to design systems using both hardware and software, or a combination of the two. There aren't many courses like this around. You tend to either do You could think of this as electronic engineering and computer science put together. That's kind of one way of looking at it. A lot of courses that tend to be either computer science or software engineering, where you're focusing on software development, or electronic engineering, where you're focusing on hardware development. Here we're looking at both in combination, and that's really important because software developers increasingly need to know a lot more about the hardware that their software is going to run on, and vice versa. You can't really be an electronic engineer these days without being able to program. And this course gives you that sort of skill set to sort of move between hardware and software development, or a blend, increasingly these days, a blend to designing systems using both hardware and software, and deciding where that split is going to be between hardware and software. We see two core subjects making this up, therefore. So basically, you're kind of studying electronic engineering alongside software engineering with a roughly 50-50 split, 50% split between the two. Very similar, and in fact there'll be some shared teaching with the computer science course for this reason. And in fact, this is where, as David said earlier, that there is this flexibility, especially in the first year, for you to hop between courses, because there is that similarity between the courses. Robotics is a big area. Our philosophy on our robotics course is modern, intelligent and autonomous robotics. So really, now robotics has actually been around for quite a long time. We traditionally think of robots as being sort of stationary installations in a factory. And sure, we cover that kind of robotics. But what's really taking off now is that sort of robotics is sort of small robots starting to enter our everyday lives. Robotics is starting to enter all sorts of areas that they weren't in before. For example, medicine, we're starting to see robotics entering into medicine, farming, and so on. And this is the robotics industry is mushrooming now. It's really taking off. It's going to be over the next few years, it's going to be one of the biggest industries. And this is due to robots becoming more autonomous and more intelligent. So again, it does draw on courses as well. So machine learning, artificial intelligence plays a big part in robotics. Again, electronic engineering. Now, robotics is very interdisciplinary, but we've distilled it down to sort of three key areas. One is machine learning, artificial intelligence. So that's the intelligence of a robot and how it can become autonomous. There's a sort of hardware side of things. Electronic engineering is a key aspect of robotics, as well as computer science. How can we develop software for robots? How can we program robots, if you like? So those are the key aspects. But if you go into robotics, you can be looking at lots of other areas as well. So psychology impinges on robotics. There is a synergy between biology and robotics, and so on. So it's a really wide area. Now I think this is the last course we're talking about, but just to say that, so on robotics, you learn a large skill set. You learn programming, you learn hardware development, similar skills that you learn on the other courses. And whichever of these courses you do, you're going to be really valuable to employers.
We try also to inject into the course our background. So, for example, I'm just thinking about myself, Mark, and Anurad, and our colleague, and Raouf. So, what we are trying to do is also, for example, to talk about, to try to do this, we call research informed teaching. So, for example, Anurad is an expert on haptics and human-robot interaction. Mark is an expert on biological inspired robotics. Raouf is more on intelligence and so on. So what we are trying to do is also to transfer this into the course, especially in the last year. So it's nice because you have a flavoring of what is going on also in the research field, and we're trying to put you on the cutting edge things, you know.
Thank you.
Yeah, just to add to this, I'm currently in the process of reviewing proposals for the European Community Horizon 2020 on a special program on Corona, on COVID-19. And the core of the call is on the deployment of AI and robotics in various settings, hospitals, communities, elderly people, and so on. So it is very much a very hot topic now.
Mm-hmm. Okay, thank you. So I think just to finish off with, we'll just look at the assessment patterns on the courses. This is where, just to say that I mentioned at the beginning, you can do a 3-year undergraduate course, so BSc, BEng, or you can do an integrated master's. So the BSc or BEng is just a 3-year course, or 4 years if you do the optional year in industry. And the year in industry slots in between the 2nd and 3rd years. So you do your first 2 years, you then do a year in industry, and then you come back and finish your degree. The integrated masters basically is the same as the 3-year BSc or BEng up to the 3rd year, and then you do an additional year that gives you a master's level qualification. That's the difference between the integrated masters and the normal undergraduate. They're the same for the first 3 years, or 4 years if you're doing in industrial placement. But you just do this additional year to give you the master's level qualification. So in the first year, all courses are roughly a third exam based, and then 2/3 coursework based, roughly. In the second year, it drops down to 25% exam. These are very practical subjects, so this is a sort of pattern that works quite well for us.
Yeah, the critical thing here to note is a lot of other universities just have exams at the end of the term.
Sure.
Whereas we see these subjects as very practical. So you'll see a high percentage of coursework on all of these courses, and in fact, they're used hot off the press. I don't know if we should say this for the Senate the other day, is they're actually thinking of getting rid of the exam for the first year, but that's still under discussion at the moment.
Yeah. So second year it drops down to 25%.
So it's a bombshell.
75% coursework. Third year, still 25% exam, but we have this 25% research project. This gets called different things in different places, but research project, dissertation. This has been mentioned by a couple of people throughout the session. This project is a major independent piece of work, and it's a chance for you to sort of show off what you've learned on your course, and to really get stuck into a particular topic that interests you. Yeah. So 25% on the project there.
Yeah, you'll be assigned a specific person to do your research with. So one of us, you'll have you as your project manager, as you like. You've got to have regular meetings with us, and we'll closely monitor your dissertation as it goes along.
Yeah.
And to be honest, the project is really important, because at the end of it, when you go out there to get a job or do some research somewhere else, it's very often the project that swings it, because you've been focusing on that for the year, and you've probably come up with something that they haven't seen before. And that, if you can basically use that as a selling point for you, or the research that you're doing to take it further, it's really valuable, the project itself.
Indeed, yeah. And then 50% coursework. I'm not going to spend too long on this, but just to say that if you do an integrated master's, the exam drops down further, and you do quite a large percentage of coursework in the master's year of the integrated masters. By the way, You can choose to do either and swap over. So you could just come in to do the normal BSc, BEng. Sorry, by the way, the integrated masters is only available for the single honours courses. So if you're doing joint honours or combined honours, mathematics, computer science, information technology, you don't do the integrated masters, okay? Or that's not available. So you've got this large chunk of coursework in the masters level. Lost my train of thought there. I'm sure there was something else I was about to say about the. Oh, sorry, you can swap between them. Yeah, that's it. You can come on to the normal 3-year course, 4-year course with placement, and you could choose to go on and do the 4th year before you graduate. So if you get into your 3rd year and you think, actually, I prefer to carry on and do the integrated masters, you can swap over and do that. Similarly, you could apply for the integrated masters, but you could choose to exit with a BEng or BSc after your 3rd/4th year. If you decide not to go on and do the master's level, you can exit. So that, again, lots of flexibility basically. I think that's it from us. Just to say, have you got any questions? If you've got any questions, please do enter them into the Q&A. Just to remind you, there's a Q&A icon down at the bottom of your screen. Feel free to type questions in there, and we'll answer them. Otherwise, thank you very much for coming along, and we hope you apply and would look forward to seeing you if you do so. Thank you very much.
Thank you.
Thanks.
So I'm just going to see if we do get any questions, and I'll try.
Yeah, we could either do it on Q&A or chat. Actually, you can do it both ways. So if people want to chat or just do it in Q&A. You can monitor both at the same time if anybody's got any questions.
Okay. We'll just give people a couple of minutes. No questions so far, but we'll just give people a couple of minutes. Do feel free to post any questions if you have any. Just while we're waiting, just to reiterate, because there was a question during the presentation, and I did answer it during the presentation, but just for anyone who's watching the recorded version of this, there was a question earlier on, where do the courses take place? Everything takes place in the Francis Mary Lesher building, the FML building, on the Hope Park campus, which is in Chilwell, Liverpool.
There's a question.
Oh, sorry. Okay.
Yeah. How does the computer science course go into cybersecurity? We're actually developing the cybersecurity thing.
There is some cybersecurity, isn't there?
Well, that's what Mark's developing cybersecurity in the 3rd year. Yeah, so it will do that. We're basically pumping up the cybersecurity because it's obviously such a hot topic at the moment that we're actually developing a new course to go into the 3rd year on cybersecurity. So yes.
And also, one of the lecturers that is teaching in computer science, actually, he has completed some years ago a PhD on cybersecurity.
That's right. He's not actually here at the moment. It's not my area, but it's in fact a couple of the other lecturers who aren't here are cybersecurity experts. Neil in particular has done stuff. He's done lots of research on things like secret sharing and cybersecurity and stuff like that. And Mark's developing a course on it. Okay.
So the short answer is, I think you can expect some cybersecurity in there. Yeah.
There'll be quite a lot really in the 3rd year. Okay.
Yeah, so just to finish off, I was answering that question from earlier. So the School of Mathematics, Computer Science and Engineering occupies the top 2 floors of the Francis Mary Lesher building, FML building on Hope Park. And almost all of the teaching takes place there. Some of the lectures might take place on other parts of the Hope Park campus. It's not a large campus, so there's not a lot of moving around. We'll just give it another minute, and then I think if there's no more questions, we'll end it there. So just another minute or 2, if anybody's got any further questions.
I think we have a Kapil among the students attending, so maybe Kapil can make a question.
And Graham. Have you guys got any questions? That's an interesting combination that Sophie May's actually said that she's going to be doing, which is computer science and criminology.
Mm-hmm.
So it sounds quite an interesting combination, really.
Indeed. I'm guessing we're not going to get any more questions, so I think we'll close it there. Thank you very much for coming along. Thank you.